Hi and Assalamualaikum. My name is Noriza binti Rosli with my matrix number 203247. So today our group number 5, will present about STORM project. So let's go. So these are the group members. First is Muhammad Azad Hafizuddin, then Siti Hawa, Nur Faris, Nur Sofi Alia, and lastly me. Okay, so let's start. For the step 1, we have is the after storm. So the step is we add our image, which is geo underscore C26177240, our picture from the storm project folder. So this is the image, the result. Next is the step 2, is the before storm. So as usual, we add the pre-image from the storm project folder. So this is how it looks like. Okay, next is the step 3, the houses. So step 3A, from the step 3, we need to map and record the house damage using the before or after storm. The image on a scale from 0 to 10. So it is the dependent variable for our project. So to start it, we need to do this step first, which is step 3A. We need to create houses in shapefile, mark the house on the pre-image, as you can see on the figure. So first step is we need to create the new shapefile, then right click folder home. Next we need to click new, then click the shapefile. Then we need to rename the shapefile as houses underscore group 5 as our group names. Then we need to add the houses underscore group 5 as the layer at the box section. Next we open the editor toolbar, then we click start editing, so that we can click the create features. Next we choose any shape and color to mark the houses. As you can see from the figure, we choose color purple, and the shape is circle. So we just are going to put on the house to count the house. Next we click on the houses underscore group 5, then we start count all the houses. So the total number of houses that we counted is 404. Next, step 3B, we add fill. We right click at houses underscore group 5, then we click open attribute table, then click table option, then click add fill. As you can see, the red circle, we have made it square, so that is the result we need to add. Next is step 3B. We need to rename the field to app underscore damage. We rename it, then we choose double for the type section, then select 1 for precision and select X for the scale. As you can see from the figure, that we put the number. Next is step 3B. We need to add underscore damage. We use the before storm image, then we click start editing. We rate it using the scale of 0 to 10 to determine the damage of the house after the storm happened. Next, we're going to compare the condition of house before storm and condition of house after storm. So by that, we unclick layer pre-image to see the condition before storm. So this is the result we get. Okay, so this is the clear one. This is the image of after storm image of the red app underscore damage. So you can see from the right side is the table, and the left side is the image. We use this after storm image to record the description of 0 to 10 into the attribute table under the field called app underscore damage. Then after that we put, if we put 0, it is actually there is no apparent damage, and if we write 10, it is actually destroyed or gone. Actually, it is not easy to see the damage from above, but actually it's in reality, although the house may not appear damaged from above, it may have been flooded and is ruined. So from that, we use the 0 to 10 numerical description to know, to state the condition of the house. I think that's all from me. So continue, Adus.
Okay, good morning and Assalamualaikum to Dr. Nur Azwan, my best group members and all my fellow classmates. Thank you, Izzah. And my name is Nur Faris binti Suleiman, 202472, and I will continue to present and explain for the next step of our group project, which is the project is about Storm project using ArcGIS software. Okay, next. For the next steps that we need to do, that is from the puzzles folder, we need to add in puzzles underscore 2008.shp and also the puzzles underscore 2009.shp. Okay, for a little bit of information, shp is an open data format that is widely used in the industry. Open data for ArcGIS automatically convert our data to shape files, which is shapefile is the short form for SHP. Okay, it also Open Geospatial Consortium.incorporate formats such as a keyhole markup language in comma separate values. We can filter, visualize and analyze data in addition to merge it. Okay, for the next steps, that is the 2008 data is pre-EK and 2009 data is the post-EK. Okay, after that, we can look in the attribute tables for puzzles underscore 2008, which is val 08 land is the value of the land that only in year 2008. Meanwhile, for the val 08 IMP is the value of the improvement, that's the house or other constructed building only for 2008. Okay. Then for val 08 tot is the total, which is it show the attributes for puzzles underscore 2009 is similarly constructed. Okay, for our project, for our analysis in this project, we care most about the improvement, example as housing the damage. Okay, here is the figure after we adding the puzzle 2008. Okay, this is what we get from the ArcGIS software. Okay, this one. The next is about a figure when we add puzzles 2009. Okay, for the next steps, that firstly we have to unclick the pre_image and then we click right on the puzzles 2009. Then we click zoom layer. Okay. Secondly, we need to right click on the puzzle 2008 and then open the attribute table. From that, we click the arch toolbox, then projection and transformation. Then we click define projection. Okay, for this step, it is for define projection. Okay, the next is right click on the house underscore group 5. This one from the folder that our group created. Okay, click joins and relate, and then after that we click join. Okay, we need to do all this step back for the puzzle 2008 and also for 2009. Okay, here is the figure that I mentioned before. Okay, here is the join output and join output tree. This is from our folder of group 5. Okay, this one is the puzzles underscore 2008 for folder, and this one for folder puzzles underscore 2009. Okay. Okay. Next steps that, okay, first we create a new field in the house underscore your last name goes here .shp file, and then we need to calculate the change in improvement value pre and post storm. Okay, then we need to call it as a change underscore imp. Okay, we do this for the land value, calling it change underscore land, and the total value calling it change underscore total as well. Okay, here is the figure or the data that we can get from the software. Okay, we get the value, this one of from the early I explained that val08 land, okay, value for the land that only in 2008. Okay, for the val08 imp is the value that house on the constructed building. Okay, and then val08 thought is the value of the total that contributes for the construction or housing damage because of the storm. Okay, this one for year 2009. Okay, and then from that we calculate the total of the 2008 and 2009. Okay, for change total, this value we get from the value val08 thought for the year 8 2008, and also for val09 thought we minus 2009 years with the 2008 years, so we get this value. Okay, and also like before, this is the instructor. Okay, this all the value that we get. Right, this one. Okay, next that is, okay, we need to find the distance to the shore for each house. Okay, first we need to create a new vector file of line, which is, we call it shoreline, but we use the same projection. Okay, then first that we need to click the catalog, and then we create new vector folder, then name it as shorelines. Okay, then we click at the right click on the shorelines, we click new and click file geodatabase. Okay, here is the figure that shows from the ArcGIS software. Okay, here what I mentioned before, which is about the folder of the shorelines. Okay, here is the step. Okay, shorelines, click new file geodatabase.gdb and then choose the shorelines. Okay, click new database. Okay, click new, then click feature class. Okay, after that the next is, in the future class, rename it with the shorelines. Okay, choose line feature, and then after that click projected coordinate. Okay, after that click UTM, and then we choose the 1983 zone 15, and then we click next, and then folder shorelines appears on the catalog here. Okay, for the next, okay, this one is the figure that a folder appear, and we name it at the shoreline as I mentioned before. Okay, and then we choose the type of the features that stored in the feature class for line feature. Okay, we then click next. Okay, after that, the next step is that we need to digitize the apparent shorelines, which is before the storm, DOQQ imagery, into this file. Okay, first that we need to start editing. Then we choose the shorelines. We click the icon edit, and then it will appear like this. And then after that, we choose the shorelines, and then click OK. And then we continue, and then click feature, show lines, and then after that, we show this one, like the arrow, right arrow, choose line. Okay, next then, we draw the line from here, start to the end. Okay, then we need to double click on the line to stop edit. This one show the distance. After that, the next step that we need to find the shortest distance for every house point to the shorelines that we already draw here. Okay, and then we call this field as a dis underscore shore. Okay, we will make it type double, precision 8 from the scale 1, and put it into the house underscore your last name goes here .shp file. Okay, after that we use the measuring tools to measure the distance. And then after that, put those measured distance into the this underscore shore field. Okay. The last step is that round our value to the nearest meter. Okay. That we need to do is click the arch toolbox, and then choose near. Name it as the feature to our house underscore group 5 name folder, and then we click near feature, and then choose shorelines, and then after that right click on our folder that house underscore group 5, and then we open the attribute tables. Okay, here is the from the software ArcGIS. Like I mentioned before, input feature that under our folder group house underscore group 5. This one appear the arch toolbox. Okay, we choose the near, and then click right, and then we will become shorelines here. Click OK. Okay, so this one is the figure that show the attributes tables that we want the data about the nearest distance from the shore to the house. Okay, this that attribute tables, and from the data we will get all the details about the distance. Okay, and that's all from me. And thank you, and my friends will continue to present. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Siti Hawa binti Fakhruddin. So thank you Faris for presenting before. So now I will continue for the procedure in step C. So firstly is about step 6A, which is we want to add a storm center in our ArcGIS. So we need to create a notepad file. So we just copy this sentence that we can find in the storm project instruction and just paste on the notepad like here. And then we save the notepad file and rename it to as Storm Center. Next, we proceed to step 6B. So this step is about adding the notepad file that we have created into the ArcGIS software. So we need just to click XY, click add XY data that we can find by clicking the file button on the left corner of the screen. Then this folder will appear, and just find the Storm Center text, which is the notepad file that we have saved before, and add the Storm Center text. Then we need to make sure that we need to change the projection of the file and change it into projected coordinate system, and then choose UTM-NET 1983, and then choose UTM zone 15. Then just click save. Okay, next, we must convert this the notepad file that we have created into a shape file. This is to ensure that the file that we create appear on the layer of our GIS. So just right click on the Storm Center text on the table of point time, and then click data and click export data. After that, we rename the layer into EK Center, and the type is shapefile, and then click save. Next, we have created the shapefile. So here we can see the Storm Center text under the layer. So just right click on it and click zoom to layer, and we can see the Storm Center on the layer of ArcGIS. So we can also see, we can also open the attribute table of this file, and here we can see the coordinate of X and coordinate of Y of this point. So that's all for step 6. Now I will pass to Sophie to continue. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Nur Sophie Alia binti Sharul Anwar, and my metric number is 202692. Now I will continue to explain on how our group performs step 7 of the STORM project using ArcGIS software. Okay, for step 7, we need to find the percent cover for each land use land cover, in short, LULC type, that falls within a distance of 10 meters from each house. Okay, first and foremost, we create buffer at a distance of 10 meters by clicking geoprocessing and then buffer. After that, input buffer will be displayed, and then we add house group 5.shp in it. While for the output feature, we rename it as buff_10. For the distance, we set it with 10 meters. After clicking OK, the buffer of 10 meters is created. Okay, as shown in this figure, this is the result we got after performing these steps. We can see small light yellow circles on each house in the before storm image. Next, for step B, we just repeat the previous step, but to create buffer 50 meters. Then the result will look like this. We can see the difference from the previous figure. The size of the circle has bigger diameter, larger diameter, and we set it with light blue color. Alright, for step 7C, we just look at the LULC final raster file from our folder to take note the metadata. Then proceed with step 7D. In step 7D, we convert the LULC final layer into vector. To perform this step, we go to Arc Toolbox, find Conversions Tools, click Raster, and then click raster to polygon. Then we automatically got the image as shown in this slide. Okay, we name this image as vectorized LULC. For the next step, which is step 7E, we reproject the vectorized LULC to fit the same projection as houses group SHP. To perform this step, we go to our toolbox, then data management tools, then click projections and transformation, then click feature and project. Then we make the vectorized LULC as the input file and name it as vectorized LULC reproj. Okay, that's all from me. Thank you for your attention. I will pass to Azad to continue from here.
All right, thank you for letting me continue this presentation. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, I continue with step 7F. So, which is to visualize the various color for each LULC type. So, first we go to the properties and then click for symbology, and then choose categories, and lastly choose the unique values. Then make the value field as grid code, then add all values. So from these 4 pictures, it shows the various colors for each LULC type. Yes, LULC type. So move on to the next step, which is 7G for buffer 10 meter. We intersect vectorized LULC reproach with buff 10, like the figure below at the left side, and then name it as LULC buff 10 intersect. And this is to obtain the numerous LULC values surround each house and coordinate them simultaneously with the FID numbers from the buffered house file within the attribute table. So the right side of this slide, right below, is the output of this step. Next, for the buffer 50 meter, we repeat the same method like for buffer 10 meter, which is intersect vectorized LULC reproach with buff 50, and then name it as LULC buff 50 intersect. And then same as the previous figure, but this is for buffer 50 meter. And next, I proceed with step 7H, which is called calculate the area. So first, we open the attribute table in houses group 5, and click table option, click add field, rename to LULC buffer 10 area, and then choose type long integer, then click OK. And the figure below show the output of all this method until you click OK. And then the right click on LULC buffer 10 area field, click calculate geometry, then click yes. We can see the figure of calculate geometry there. It's same as the steps that I tell you just now. And then we click OK, then click yes, then repeat the same step for LULC buffer 50 area. And the output of the method is at the right side below the instruction. So that's all for my part of this ArcGIS. So proceed to the next presenters. Thank you.
Thank you, Azad, for presenting. Now I will be back to proceed with the step 9, which is adding lighter data. So first step is 9A, adding the LiDAR data. So this LiDAR data can be found in the LiDAR folder of the STORM project folder. But we need to first, before adding the LiDAR data, we need to enable the DEM to raster to before we can add the LiDAR data. So just open up Toolbox and choose Conversion View, and then click to raster, and then click the DEM to raster. Then after that, we can add the LiDAR data in the LiDAR folder, which is U299435_4_B. Then we rename the output raster as the same like the input, and then click OK. After that, we repeat the same step as above for the another two LiDAR data. So after doing that step, we can get the output for the three LiDAR data. So here is the first output, this second output, and this is the third output. So LiDAR data is in gray color. So this is the gray color of the of our. So after working on steps 9A, we can proceed with step 9B, which is finding the value from the top of the house. So the steps are followed as stated in the STORM project instruction. However, after working on all the steps, the ArcGIS software stopped working, and this appear, the GIS stopped, and this message appear. So we just repeat several times for the same step, and the outcome is still the same. So we can proceed these steps, and our group only managed to complete all the steps until here. So we continue to complete our reports and just doing all the results that have been presented. And as for the discussion part, we explain it in more detail in our report. However, since all the steps have been done, not all the steps has been done, so not all results are obtained. So we just do the discussion on only the result that we have obtained. So we only discuss on the factors that causes the hurricane, on the factors that we have we can obtain from the steps on the Hurricane Ike that hit the Upper Texas coast. And then we also summarize all the steps that we managed to do. We also discuss about the errors, mistakes, and problems that occur during our project, and as well as the advantages and disadvantages of this project. So these are the presentation of Group 5. Good, thank you for listening. Thank you.